Whatever. Let's get started.
Not accepted.
It's really bad when you see yourself. So good morning. If this is a surprise to you, it's because you might be into Docker files, that's the other room, or if you're into logging, that's the room. So if you're really into load testing, welcome. That's me. I'm an old programmer, so I touched Java 1.0, and I'm load and performance testing since '99 and programming for quite some time. That's the company that basically paid the trip here. It's called Acceptance. We have headquarters in Germany and a subsidiary in Cambridge, Massachusetts. We do performance testing and all kind of other testing, but today it's about performance testing. And by accident, we wrote our own tool. And this is basically about that tool. This is open source, so this is not a product pitch itself. I want to sell you anything. I might, but at the end of the day, it's really about why we wrote our own tool, why we spend so much money and have not really utilized what we spent so far. By the way, because we are just a few, if you have questions, feel free to ask questions. And by the way, this is a brand new presentation. I don't know if I need 45, 50, or 2 hours. We'll see. By the way, this presentation is Creative Commons, so whatever you see here, feel free to share, as long as you say where you found it, and if you present this under the same license. Good. A little bit of history. My work before Acceptance was at a company called InterShop, one of the first e-commerce companies. I was later head of QA there, and we had to do load testing at a certain point in time. You know, e-commerce, a lot of traffic, stuff like that. And at this point in time, we had just commercial offers. So one of these guys came from Segway, and they presented their tool, SilkPerformer, but also the Mercury guys there. And this is all now being owned by Micro Focus or something like that. So it has been sold several times. And they pitched the product and said, hey, you know, and they did this quite well. So we decided, okay, we sign up for that. At this point in time, it was just Microsoft Windows. It was cool for us. There was a scripting language in it. It's kind of Visual Basic-like. At the end of the day, I saw that this is not really a language. It's kind of a whatever heck it is. The APIs were really, really bad. It needed a DB server to basically do certain things. And then, of course, no open data, no cool protocols to do remote communication, stuff like that. And some oddities. And the largest oddity is the price, because we paid $500,000, and sorry, I can't remember if this was euros or marks, but it's still an insane amount of money for about 20,000 concurrent users. No hardware, so we had to buy 600 blade machines we put in our basement of our facility at this point in time. It's a huge rack, I couldn't find a picture of that anymore, with these blade servers. And for every year, we had to renew the license support to get upgrades between 15 and 20% of these 500K. Insane. So, when we started basically our company, our first large customer in the US said, we want to do load testing. I said, okay, fine, cool. We don't want to do a lot of load testing, and we might also later have projects where we have to do load testing. I said, cool. But we're running on Linux. I said, cool. And cloud was not yet a thing, because it was 2006. When did the first real cloud offer came from Amazon? August 2006. So EC2, and I looked this up, basically the first compute instance was available in the US, East Coast, in August 2006. And basically most people said, Amazon machines? Doesn't make any sense, what the heck? So it was not yet a thing. The problem is money. The startup basically had no money, and we as a startup had no money. So the big guys basically were kind of out of question. And the problem with the big guys is if I, as a consulting company, purchase a license, they say, no, 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 you can't do load testing for a customer. You have to pay extra. What a stupid idea. So I said, maybe JMeter. JMeter was a thing at this point in time already. It was not yet an Apache project. version 2 is something. But I really couldn't get used to the UI. It was kind of the filling around and clicking here and clicking there, and it was kind of, I'm a programmer, this is not my thing. And of course, you couldn't debug stuff like that, so, nah. And then we said, let's write our own tool. We are software engineers, we can do that. So we started our own tool, rolled our first version, and said, okay, I'm a Java programmer. The customer is running a Java stack. So let's go with Java and make this the scripting language. So we picked Java. Then we said, okay, we don't want to do the request level. We would just really want to have a form, fill it out, and send it. So make it comfortable. So we said, okay, HtmlUnit might be our thing. So we picked HtmlUnit. It's still an active project, by the way. We are part of the maintenance crew. Apache HttpClient, the GDK HTTP client at this point in time was really, really bad. And up to version 11, it was still really, really bad. So therefore, most people picked Apache HttpClient. We right now basically have 3 clients available within, or 4 to be honest, but it's a topic for later. Charts, J3Chart was an insane good library at this point in time. It's still a good, insane library. It was GPL at this point in time, but now it's, I think, a different license. And then JUnit, because, if you're a programmer, you know what JUnit is, so let's pick JUnit as the container. And then it must fit a version control system, because we found it kind of really inconvenient to have load test configurations hanging around on a machine in a very strange format, and everyone just types this into it. So it's like everything you do has to fit version control. So we said version control. And then, of course, the naming of the other tools were kind of strange. So we said this has to change too. And this was our first load test result, right? And if anyone here uses K6, it looks similar. So we haven't been far away from what K6 produces by default 17 years ago. The thing is, there was no scale yet. What we basically did, we started the load test on 8 machines in proper configurations, and then we just copied the results together and created a report. It worked. And we had charts. Not nice charts, but we had charts. Really kind of okay-ish charts at this point in time. So we said, maybe that's okay. Let's go with it. And because as a consultant company, you get new customers and say, okay, the tool is good. Let's use the tool. We continued to use our tool. And of course, we needed naming. And as a software engineer, you come up with a stupid abbreviation. So we said, yet another regression test tool. By the way, this was a very stupid decision, and we'll explain later. Nowadays, it's called XLT, Acceptance Load Test, which is also a bad name. And we will have a contest at the end of the day for more. So this name will go away in a few, because yard is very close to an Arabic word as well. So it was a kind of a really stupid one. What we found out, the most important thing in load testing is data, and importantly, how you present the result. So we said, okay, let's see what the others have done or do, and make it better, because what SilkPerformer produced was horrible. What get from JMeter by default is kind of So at the end of the day, every chart you see is a trap. So we wanted to avoid this trap. So here are a couple of charts from load test tools. This is one. By the way, it's a big CDN provider who purchased a load test tool from someone else. This is SilkPerformer. Awesome, isn't it? This is another common load test tool. Not very popular, but it's also a product offer. This is Gatling, which Gatling wasn't a thing at this point in time, by the way, but still kind of charts go nicely with all the others. And this is LoadRunner. And this is basically the result of a load test done by a customer. While we were doing a load test, they were doing a load test too. Not at the same time, but they're basically running stuff. And they presented us with these charts. And by the way, this is really bad resolution. That's all I have left from that project. But it basically tells you a story that it doesn't tell you a story. So let's do it differently, shall we? And this is our chart. And by the way, this is not the right one. This is the one how it would look like if I would just do what all the others do. And by the way, is this a good load test result or not? What would you say? Yeah. Well, the P50 is basically here, which is 250 milliseconds. The mean, yeah. And the P95, we'll show you this in a minute, is okay. But the thing is that this stuff, and this is a default chart similar to all the others, hides most of the problems because this is reality. And this is what we produce by default, and I call it reality chart, because what you see here is these small spikes that occur in kind of fixed intervals, something you wouldn't see in all the other load test tool charts. And then you see this here, where it goes really bang with up to 15 seconds runtimes. So what we do here is to say all in seconds, so the best resolution is actually seconds. So if you have, let's say, 10 results within a second, we take the min, the max, and we do a mean. And this is what you see here in the plot. So the max will never disappear, the min will never disappear, will always be plotted, and then there's something in the middle. So you actually see that you have a problem coming by seeing this rhythm of things going on, and then you have the problem. And this is the reason why we designed the charts that way. But of course, we learned it also the hard way. In the beginning, it was kind of slightly different. And later on, we came up with, we want to see this. What can we do? And if you plot every point, every chart software will explode. So you have to reduce the amount of data you basically show. And by the way, I will post the presentation later on Twitter. You can then just basically scroll through. And once again, everything you see here is yours. Good. Another example, just a nice one from a test homepage UK. And you see a couple of data numbers. The P95 is actually quite good with 550 milliseconds for the criteria we used in this case. But you can see there is something going on. So the software is not performing as well as it should be because you have this odd 4 to 5 second noise level, constant. So it could be that the load balancer is not performing well, the connections are not starting well, something like that. You would never see this in others, so it's important for us to actually show this to our customers. And this is basically the report that comes out at the end of the day. And we can just click it. And then you can see all the details. We see basically all the requests, what they produce, the overview table. And then you have basically for every different type of request, you have your own chart. Okay. If you're interested, we can talk about this later. We also said we need something to compare load tests by default. So we have test A, test B, and this is such a table that basically comes out at the end of the day. And we also have nice coloring, so you immediately see where the problem is. Good. Okay. And we said, okay, we are programmers, we can do something different. Let's do something different and come up with a really good idea. And you remember the name? Yet another regression test tool. By the way, because Yard is 1 T and the other one has 2 T's, I don't know why I came up with that, but at the end of the day, we said, it's a regression test tool. We have to have test automation. So let's build test automation into the tool. So we built test automation and said, why not do load testing and test automation with the same scripts? That would be awesome, right? So we basically built it. And this UI is based on Firefox. Xul was an API language for user interfaces. The entire Firefox was written in Xul, kind of JavaScript API interfacey thingy. So this was running within Firefox. It was kind of doing okayish, but it was a very expensive mistake. Why? Well, because browsers are evolving so quickly that the load test tool and the scripting basically divert quite quickly. Because JavaScript in HtmlUnit, which we used for the browser emulation, is very much different from what's running in a browser, because the ECMAScript standard basically just quickly evolved. The tool couldn't keep up with that, the library. And if you don't render a UI, JavaScript basically says, I need a size, I have to do something. The size is not there, there's an exception. So JavaScript depends heavily, in most cases, on UI presentation. At least 50% of the JavaScript you have, so was a problem. And if you run a real load test in a real browser, it's going to be expensive because the browser eats easily up a lot of the CPUs you have. So, and then there was Mozilla, and Mozilla said in 2013 or something like that, by the way, Xul, stupid idea, security problem, let's deprecate it and it will be removed from Firefox. And we said, okay, and now? It's, well, we could go with WaterFox. Anyone knows WaterFox? Which basically is a clone, or not clone, it's a fork of Firefox, and they continue to have Xul. But then we said, okay, the problem is that if you are in a big corporation and you say, I want to install WaterFox for the tool, they say, what? WaterFox, it's not approved by security. Yeah, okay, so basically the entire tool died at this point in time, not the entire one, but the test automation part. So 7 years down the drain, and we tried again and tried to do this with Eclipse. We failed because we might have not given the developers enough direction, so they were kind of lost in ideas, and it was really stupid. After 3 months, we stopped the entire project. And it might have cost us €500,000, the entire endeavor, to go test automation, do this, have a UI, maintain it, and then after 7 years, it was basically toast. So if you have WaterFox and you can install this, you can still run our tool, our UI, our test automation. But nowadays, there might be better alternatives than what we produced, 13 years ago. So $500,000. It was bad, but there was one thing that remained. We can still load test with real browsers. And I think we might be the only tool, or maybe only one of 2 tools, we can actually use a real Chrome and drive a load test with it. So the thing is that you write actually test automation with WebDriver, and then we scale it up and run 500, 600, 700 browsers at the same time. But of course, you have to pay for that, because not doing JavaScript emulation and request emulation costs, and the Chrome easily uses at least 500 megabytes of main memory and 2 cores. And then it's very gentle to the machine if it uses just 2 cores. Just observe what Chrome does to your machine when it's idling. It's not Chrome's fault, to be honest. Most of the web pages with JavaScript are so bad that there's still some stuff running in the background, and JavaScript. So, by the way, web is a mess in sense of how much energy it consumes by not doing anything. So if you have a web project and you see that your Chrome idles, just see how many users you have and then come up with an idea how much this JavaScript within your Chrome might cost the world at the end of the day. There was once someone doing snowflakes on an e-commerce site in JavaScript, rolled this out to 1 billion users just to have a Christmas animation. And you just can calculate how much energy this has just costed to display these snowflakes for 1 million users at the end of the day on their CPUs. Good. So, by the way, there's one nice thing is by running on a real Chrome, we can get live metrics from the rendering engine, which are web vitals. So how fast is the page drawn, what kind of changes you can see. And we all funnel this off into our reports. Good. And then, of course, it's about data. In this case, Lieutenant Commander data, for all who are into Star Trek. And just give you an idea how much data we're actually dealing with at the end of the day. And this is a typical load test we run for a customer. It's a huge American customer, Bath and Body Works. I don't know, maybe you have smelled one of their candles. So they're 3-wick candles in glasses, and you just basically, they have fragrances like marshmallow or cinnamon bun, whatever fragrance this might be. But this is basically a test, and they do really well during their special Candle Day. It's called Candle Day. They really made it a holiday. And they're really selling things like, sliced bread, as the Americans say. So we run one of these from 7 data centers. And this is what the tool sees. So we have test cases that's basically kind of your scenario you're running. A transaction is a visit. An action is any kind of page interaction customer does. And by the way, this is the renaming we did to the names the other load test tool used, which we didn't like, because SilkPerformer says, this is a transaction. No, it's not. It's a request. We said that's an HTTP request, so please call it HTTP request. So we renamed certain things. And this is how much data it is at the end of the day. So for a 3-hour load test, we record 3.2 billion data points for all these requests you have seen before. If you just write this to disk, it's about 17,500 lines a second, about 300,000 data points a second, and it's about 4 gigs compressed, or about 50 gigabytes of data uncompressed. So this is the amount of data we collect during a load test. You might say, why do you collect that much data? But the thing is, you can't easily repeat a load test. First of all, it's expensive because you need a lot of machines, you need destination environment, you need agreement from the customers, you have third parties involved. So just repeating a load test because you see something and you haven't captured the data and you want to run this again is a stupid idea. And if you run it again, you might not see the same problem. So we have to capture it in the first place. And that's what we do, so it's plenty of data. And we said the first load test tool needed a database, and this is stupid. You have to install a database on your local machine just to run a load test? Nah. So we made everything we collect open. So it's CSV data, it's documented format, you can parse it yourself if you like. You can later on go into this and just see what's presented there. And we also have an intermediate presentation in XML. It's basically all the data we crunched. Give you P95s, P50s, means, whatever. And then, does anyone still know what XLST is? XSLT? Oh, are you still using that? Oh, good. Because we still do, which is very old technology and was once hyped. But CSS is not that hyped, but it's very important. Or maybe it's hyped, I don't know. So we use this for styling. The idea is here, the customer can change our HTML presentation and change the reports. And if you want to make it a different color, a different branding, you use CSS. So it was the entire motivation. And by the way, no customer ever changed the HTML. And we changed once, just for a demo, the look and feel of a report to make it customer branded. So it's nice that we have this feature. There was no need for this feature. But it gives us the opportunity to actually maintain the reports kind of nicely and evolve on the reports. So we wrote our own tool, we continue to maintain it, and certain reasons came up during our lifetime, load test lifetime, which we said, hey, this is good learning, this is good, we have this tool, and there's a good reason why we have it, because otherwise we could just go Gatling or JMeter or BlazeMeter and Octoperf and KS6, whatever. We're still sticking to our tool because we know there is something in it which helps us and our customers. So by default, our tool isolates clients from each other. So you might have seen before that the customer said, yeah, you have stupid load test results, you are sharing sessions. No, we don't. We can't. By default, we don't share a session. It's always a different session. It's always completely isolated from the other user scenario. There's no way we could share anything. And by the way, we are not even sharing the same connection. There's no pool we're sharing. The tool is designed in a way that your test case doesn't know that this is the test case running as a load test. It's so isolated, it doesn't know anything about all the others. It's absolutely isolated. So the typical ones we always get, nah. So we made it right in the first place, which was good, because we knew already that most of the customers will ask us these questions because I got burned with SilkPerformer before. And then we said, okay, we have to make everything open because you want to archive things easily. You can't archive a database easily. You can't archive a kind of a shared report on a running UI platform somewhere easily. So everything is open. You can zip it up, store it somewhere. The report is HTML. You can zip it up. You can store it somewhere. And you can recreate a report later based on results. You don't need the same machine, the same tool. You don't need a running load test. If you want to do this 2 months later and you want to discover something else in your test, you can. And we have a use case for that, and we didn't even know. BaFin, that's the German SEC, basically the guys controlling the banks, and the guys failing controlling the banks, by the way. We are working for a German neo-broker. They are basically doing trading. You might have heard of Trade Republic. There might be even a broker here, I don't know. So they use XLT, they use load testing. We wrote a couple of extensions for them. And then the BaFin came in and said, okay, you want to be a bank, you have to be regulated. And regulation means You have to prove that you tested your software. If the customer complains, we have to follow up on that and see if you did it right. Otherwise, poof. And this basically means you have to archive your results for 10 years. And how do you archive something that's in a database? Somewhere. On a machine of a developer, somewhere. So, by accident, right decision. Make everything open, make it shareable. You can transfer it from one machine to the other. And a different developer can do something different after 2, 3, 5, 4 years to result. And if you archive the tool with it, which is now open source, so you can just basically archive it and build it, you have everything you need to do something after 10 years, which is really cool for any kind of legal things you have to do. Okay. We have a flight mode by accident. I didn't even know before that we have such a thing. So I was flying back and forth to the customer in the States, Boston, and coming back to Germany. And sometimes the load test is 8 hours, 12 hours, something like that. And what do you do at the airport? You work. Or you eat a burger or something like that. But mostly you combine both things. You work, eat a burger, and you do something before the boring flight starts. So you will start a load test. And you can close your laptop. The load test doesn't care. It continues to run. And then you de-embark the airplane in Frankfurt. You just open the laptop. You collect the results, and you get your results. By accident, this is nothing we designed into the tool. It's just kind of by accident there, and it's really, really convenient. And the good thing is, we have an emergency brake. So if something goes haywire, the agents will stop automatically and wait till someone collects the results. So at a certain point in time, if it records too many errors, it will say, no more, there's something going wrong, and it will stop. You can also download things partially. Let's imagine I stop in Ireland because the flight got diverted, so I can collect results in the meantime in Ireland and to continue to run the test at the same time. Also, by the way, an accident feature. So we haven't designed this into it, it's just worked for whatever reason. You can also get dead agents because of running in the cloud. Nothing is reliable anymore nowadays. So there might be a dead agent, so you can still get all the results. And if I am crashing with the airplane, my colleagues in Germany could still get to the load test results, even so I'm somewhere floating around. So, also by accident, but you basically, you start something, you get sick or ill or whatever, someone else can continue to work with the data. And we fenced it. It was a kind of a design decision. So what we always had with customers that they have by accident a link in the page that leads to another system. And because we are actively going for links, let's say there's a catalog link and we just check it, it's there, okay, we take it by random. It could be that it takes us to another system and then we start to load test the system far, far away. And so we can fence it and say, these are the permitted hosts, or these are the ones you are not supposed to hit, or these are the patterns you can use, and these are the ones you shouldn't. Whatever you would like to do. So if we go to wander off, we log an error and say, sorry, we stop here. You can also do really, really crazy logging things, custom events, stuff like that. And you can use any Java feature you find. There's no limitation. It's Java, it's pure Java. The entire load test is pure Java. And the only thing you shouldn't do, mess with threading, or if you mess with threading, you should know how this works, and keep the overhead in mind, because you measure things. So if your code runs long, you might measure your own code. That's really important for a load test tool, that you don't measure yourself. And then we have this load test runs, midnight, of course nobody is there. Next day we collect the load test results, and the customer says, oh yeah, there are 500 errors. What did you do? And I said, we sent a request. What request? Most tools can still give the URL. Anything else? Oh yeah, there's a timestamp. Anything else? No. But we got burned, and we got asked this question a lot. So we built something into the tool which is kind of the result browser. So if a problem occurs, it will always keep, by default, the last 3, but even more actions in memory. And if there's a failure, it will lock down everything it has seen before and everything it sees at this point in time. So you get basically all the things we send, all the things we received, all the data, everything you can find, so you can later on track down things. You get the session ID, you get logging IDs, you get referrers, you get any kind of Akamai response, request headers, whatever you might need to diagnose things, we will log it. This is one of the reasons why things are a little bit big, but that's what we do. And it's very helpful because we can always answer the question, what did you send, what did you do, what have you been doing to the bag, for instance, or the basket or something like that. So very helpful. And then we have something we call pseudo-randomness. The load test tool itself says, do whatever you want. And we say, okay, we do whatever you want. And what do? You are not going the same path all the time, because that would be stupid, because that would be running on a cache. So we do introduce randomness. But if you introduce randomness, you introduce something that's not predictable. So if you want to replay it later, you get basically a failure situation and you want to replay it, you did take a different path. So the good thing about randomness is that it's predictable, at least as long as you talk computers. So we said, okay, that we have typically only pseudo-random generators. We don't go for secure random generators. And if you give it a seed, it will reproduce the same numbers. So yeah, let's have a seed at the end of the day, spit out the seed for the error situations you have seen before. You put in the seed into your IDE, and you replay the test case, and will get exactly the same random path, as long as the environment reacts the same way. So for instance, let's say you're going for a certain product, and this product is now out of stock, but it wasn't last night. Obviously, the way you go is not the way you took before, but that's important to know. It's a lifesaver at the end of the day. Good. And you have to simulate certain load situations. And what all the other tools do is, you have concurrent users. You say you run 10, 15, 100, 100,000 users, which is not really something you should do. You should have an arrival rate. And what an arrival rate is you in a supermarket. You go into the supermarket, despite that there might be a long line at the cashier, because you haven't seen this line. You just enter the supermarket, and then you're stuck. And that's what happens in real life. You enter the system because you don't know what the system state is, and then you're stuck. And this is what's called arrival rate. So there's a constant arrival rate, or maybe not a constant one, depends on what you want to design. So for instance, this is an example of a load test done for an American brand, and they were advertising on Good Morning America. It's a very popular show. I don't know why, but it's a very popular show. And it airs 3 times, because there are 3 time zones in the States, or actually 4, but 3 main ones. East Coast, Mountain, West Coast, or Central, depending on where you are. So, and they basically said, okay, blah, blah, blah. Some VIP was talking about this new brand and this new exclusive offer, and then they were just showing a URL. And so everyone comes and wants to buy something. So we try to simulate this, and of course we can, because we built something into the tool. What I want to really show you is this. This is what arrival rate means. So the users are coming, is a ramp-up phase, the users coming at a constant rate, but your system is not constant. It's not responding the same all the time. It might get slower, and as you can see here, it really got slow for a short period of time. So more users are basically entering the store for whatever reason, but there was kind of a line at the cashier. And then you can see that this wobbles around nicely over time. So the system reacts basically to the pressure you give. And instead of waiting for concurrent users, saying, oh, we're running 50 users, if they are all in the system, nobody will arrive. You don't have the pressure like you have in the real world. That's important to simulate. So if your load test tool can't do arrival rate, it's not the right load test tool. And at the end of the day, it's all about test data. You can do everything you like with our tool. And once again, it's not a pitch, open source, Apache license, you find it on GitHub. The important thing is we take most of the data from the live system while we are testing it. Obviously, there are certain things depending on what you're testing, but we do a lot of e-commerce. So instead of going with, oh, we want to buy this SKU, we say, let's explore the catalog like a real customer does, and maybe go this way or go that way, or maybe do a refinement here by color, and then we find a product, and we might actually like it, and we might add it to the cart. So there's a lot of randomness in the system, Of course, you can restrict the random if necessary, but mostly we take the data from there. So if the product goes offline because it's out of stock, we are not running into problems. If the customer updates the system overnight with a new catalog, the load test scripts don't care, they still work because new data, I take the data from the live system anyway. If we move from URL A to B, same code but different data, we just change the main URL, we just point to the other one and the script still immediately run, nothing to update. So it is important. And this is, by the way, an example of how the code would look like. So you do something like a page design, saying, okay, click the card link, you get the card link from the page with an XPath, for instance, or with a CSS selector. Then you do certain things. And then we force you, by this construct, to think about the validation result, and you can do something to what you got back, like checking that the card really is the same number, or maybe it's empty, or whatever you want to do. One of the things we take pride in is that our load tests validate more than all the others. So what we actually do is when we arrive in the store, we check things like the card is empty, the user is not logged in, actually see a catalog and do a sign. So you do a lot of assertions on what you do during the load test. And because you can, it's just Java. You can do everything any kind of assertion framework delivers, and you can really go haywire at the end of the day. So it's important. Sure. By ID, by CSS, by XPath, or a regular expression, whatever you like. It's like test automation. You basically have to adjust if someone drops an ID or deploys new code and the card is not longer card, but it's now back. Bad luck. Good. So we can merge and split. So this is basically a login activity, which is an action. And an action can contain more than one request. So certain things are running. And you can then later on filter the result because you don't want to name every single request you fire, just want to do this somehow automatically. The tool can give you that. And it can also do things like, oh, let's filter or group by certain attributes, such as time, data center, test case, response code, by URL parts. So if you want to know if two phrase URLs are slower than one phrase URLs, kind of I go or go, you can later on massage the data, the static ones, not doing the load test. Just basically afterwards, you say, okay, I'm interested in certain more data. You can do all types of crunching. And you can do also some other things because the data is open. If you look for something that a report can't produce, just do command line magic, do a grep, do a find, whatever, and just go through the files. We have customers importing this into databases and then doing queries on it. Works. And sometimes it's important to obfuscate. So most of the data in the result is not really a secret, but you might occasionally have things like HTTP authentication in the start URLs. And you can't really put this in the header, you have to do this in the URL. And then you might want to obfuscate the things for long-term storage. And there's Java in it. And because it was Java conference, one of the reasons why I present this here is because the tool is in Java. And we learned a lot. So the entire stack is Java. The entire ecosystem we use is open source. All the things you use, we use. We learned a lot of performance. If you have to build a tool that does 600,000 requests in a certain amount of time, you really want to save on CPU and memory at the end of the day. Because if you have a target system running 1,000 CPUs, you don't want to spend 1,000 CPUs to run your load test. You want to do this slightly smaller. So it's all about scalability and performance of the tool at the end of the day. We learned a lot about memory in garbage collection. By the way, these are just a few we use. You might know some of them. And you can do other things, like one customer is running Kotlin on top of our stack. Another one was doing JRuby on top of our stack. Java ecosystem, we don't care. It works. And some of the Java lessons we learned is, we started with Java 1.3. Did anyone use Java 1.3 here in this room? Hey, cool. So, garbage collector was kind of A thing that everyone was talking about. Oh, you know, this is slow, it pauses the system. So we tuned the hell out of the CMS collector to make sure we are not running into this problem. And we also said, why not run 4 instances of the load test agent on one machine instead of one large one? It basically means the pauses are getting shorter and more predictable. And if you have a pause, only a quarter of the users is basically affected. So this is what we did. We basically separated out agents on a machine, so we can run multiple processes that are totally independent, and we compensated for all the GC pauses at the end of the day. Besides tuning the heck out of the CMS, which also helped because we tuned the heck out of the system on the customer side as well. They were running the same GDK, so we know how to tune it. It was very helpful. Now with GDK 11, we can just basically say huge VM, G1, get yourself 70%. So this is a nice feature to say XMX is 70% of your main memory, because we run on one hardware stack that's basically just us. And then we can say 1 VM, because GC pauses are no longer a thing. Only one thing: if you got burned by G1, give it enough reserved space. There's still a mistypo in it. QA guy always sees this, but only too late. But the thing is, G1 needs reserved space, so where it can basically copy things to when it runs the garbage collection. If this is not big enough, by default it's only 4% of the entire heap, it basically runs the full pause. So give it more, I'll give it 10% or at least 20, and you will be totally fine running G1 in production. Now we are on GDK 17. We're currently playing with ZGC and Shenandoah, which partially uses either less or more CPU. Garbage collection times are not longer a problem for us. It's just basically about the resources you have to apply to run a load test. What really was bad is the change of the socket implementation at the end of the day, because we are funneling off data right from the socket, how much data goes through the socket and things like that. They changed the socket implementation. First of all, it was hidden in the module. You could no longer access, so you can still open the module. And then they changed the entire implementation, so it was really painful to fix this. Also, when you go in new GDK, a lot of these libraries suddenly are kind of, they don't work anymore, which is bad, because suddenly you realize they use unsafe. Bad. And we also got to some issues where we really dealt with the C2 compiler doing something odd. We never figured out why, even asked the GDK guys why this is an issue, but GDK 21 basically took care of it. So, and we do some of the best finds. By the way, is anyone not running a CDN in front of anything public? Okay. So, when we moved our largest customer behind the CDN, we went from, we had hour-less, flawless load test results to something that always had a problem. So if you put the CDN in front, you pay with a higher error rate, and you can't influence that one. So we're always now seeing 500s, 502s, 503 caused by the CDN, not by the platform behind the CDN. So it's no longer CDN free. And we had a call with Akamai, by the way, and they said, you know, you can expect 1% error rate. I said, this is stupid. 1% error rate, this is basically being down in e-commerce. This is not acceptable. Yeah, that's normal. Okay, so nothing in life is free. But coming back to Akamai, we once had a nice case with a large customer in the US and Akamai. And if you have Akamai in front, cool. If you do load testing, you have Akamai in front, not so cool, because they will always say you are not supposed to load test us. And if you do so, here are the guidelines. You do this and this, do that, you don't do this, okay? So we were basically load testing, and we had an issue. Customer couldn't reproduce. We saw, hey, this looks bad. Okay, let's ask Akamai. Akamai said, you don't test right. Here are the guidelines. You're not supposed to use this tool. You are supposed to use our tool. Okay? Second call, no, you're not testing correctly. The third one, you are using the same session. No, we don't. We know. Oh yeah, give us more IPs. Fourth call. Okay? More IPs. We make the machine slower and run across 12 North American data centers. Give us more locations. So we added more data centers. Yeah, now you give us requests, please, and request headers. Custom headers. Here's a header you have to insert, and then you give us this header. Okay, fine, we do. And by the way, you have to use eDNS, not DNS. So what the heck is eDNS? And we said, okay, let's fix this. So we just quickly changed the tool to do eDNS, which is kind of an extension to DNS with cloud provider, stuff like that. And you must not cache the DNS entry. We don't cache the DNS entry, man. And then at the end of the day, this was the result. They had a prefetch setting for this customer. And the prefetch setting basically does this. We send a request. Request gets responded to by the origin system. Then Akamai starts to parse the content of the system and starts to prefetch links. That basically means the more traffic we send, the more traffic Akamai sends to the system. It basically multiplies things in a very kind of evil sense. So we are basically killing the system instantaneously by little load we applied. They basically quadrupled whatever or 10 times more load at the same time. So it was just a checkbox, you know. But give us more IPs, give us more locations. You don't test right. So yeah, we discovered the Cloudflare kernel issue, and we're very proud of that because we were basically sending requests, and the request never came back. Just basically disappeared. We're just timing out. We increased the timeout from our standard 30 seconds to 70, 120. Sometimes the request came back after 70 seconds or 100 seconds, but still after 150 seconds, no request came back. No response at all. It's okay. You tested wrong, prove it. Okay. By the way, the Cloudflare guys are way nicer to work with than the Akamai guys. No pun intended, but so give us details. Once again, we had a result browser. We could basically show them what we sent and things like that. So at the end of the day, Cloudflare discovered that their Linux kernel was not doing correct things when going to the disk cache. So sometimes it was just basically stuck. So they discovered that their kernel had a flaw based on our load test results. And this is what makes me really proud of. Good. I have still 3 more minutes. Let's go quickly. So we go open source. Once again, first of all, we thought, hey, we don't have marketing, we don't have sales. If we do open source, we get more customers. We don't. We don't even have more contributors. We don't have a single pull request coming from a customer. Everyone says, open source, it has to be open source. Yeah, then I can change the code. Nobody else will change the code besides you. So we started in 2007. 70 years of development went into this tool, which is now open source. We open sourced this 5 years ago. Sometimes we had 3 devs working on a tool. Started with just 1, to be honest. So if you calculate this, it's about 1.2, 1.5 million euros we invested into this tool. So was it a good idea? We might have just be able to spend this on JMeter, something like that. I think that was a good idea because we can test a lot of customers at the same time with load tests with an insane size. We don't have to pay extra. We can test with hundreds of users, no limits. We can test from all the data centers we want, no limits. And this is where you really start paying a lot of bucks to all these other providers. So it's a very good idea. The turnaround in projects also improved because we have a tool, we control, we can fix things quickly, we can diagnose things differently. So this helped despite 1.2 million we invested into the tool. And of course, there's a lot of debugging we can do, which is really, really cool. So is there a future? Now we have so much competition, Gatling, K6, and they're all funded by venture capital. We don't. So yeah, there is, and we will continue to maintain the tool. We will have GTK 21 and virtual threads soon. We will see if this saves on resources going virtual. We will have soon HTTP 3 support, which is important, and make HTTP 2 default. By the way, this is the reason why we have several agents or clients in our solution. One is GTK, which nowadays has HTTP 2 and is a better client, so you can use this one. You can use the Apache HTTP client, which doesn't have HTTP 2, which is bad. We also use Jetty, which brings HTTP 2 and OK HTTP 2. And OK HTTP brings actually almost everything. They also started an HTTP 3 project. So OK HTTP, by the way, is a very good HTTP client, just so you know. You don't have to go for Apache HTTP client all the time. OK HTTP is really great. We'll do some other things like JMeter replay. It's not for me, it's for some of our customers, because for whatever reason they use JMeter. So we kind of say, okay, you can use JMeter, and then you get our infrastructure, our reporting, our debugging, and all that stuff. We, of course, built this into a SaaS offering, which pays some of the bills nowadays. And so the conclusion, and this is almost no time anymore, we could do things we couldn't have done otherwise if we haven't had this tool, which is cool. And we never broke even, so the return on investment is really hard to justify in this case. But of course, we did 150 projects a year, or we're still doing 150 load test projects at least. And I think some of them really highly depend on what we have done with the tool. So I think it was worth the money, and we are very proud of what we did, even so only a few people know what we actually did, but we're still proud. And now we have so many tools. Would we do this now? I don't know, to be honest. Maybe we'll just go for Gatling and say, yeah, that's it, period. We've definitely not started again, because the market is so crowded that you have enough solutions. At the end of the day, there might be one solution where you say, hey, this is so expensive, I can't run it from the cloud, I will run it from my own infrastructure. And you start to build infrastructure, logic, and things like that, so invest heavily in this piece. Maybe it's good, maybe it's bad. And by the way, the only thing I would still do is pick the GVM, because it makes life easy. It has a huge ecosystem, and it's fast. And it even gets faster every time they deploy a new version. So, this is the last one. We're currently thinking about a new name. This is currently acceptance load test. You can also retitle this to extreme load testing. You can call it load torque or performulator, which is performance and simulator. Which one do you like? Quick one. Okay, first one. Second. Third. Oh, this is kind of the same. It's not really helpful. So a load torque is not as good as the others, I see. But the first and the last. Okay, good. So. Oh, we had a really long list, and I hated most of these, to be honest. Came all from the employees, and they were kind of over creative. And some of these are definitely not for the public consumption, because you can read this word slightly differently, or see it slightly differently. By the way, we had once planned a marketing campaign in kind of a QA paper, and the slogan was, made up by us Germans, give us your load. You get the joke, this is good. And our American guy said, you can't really print this, you won't, sorry, and we didn't. So, thank you very much.